Okay, today we're going to be learning about box and whisker plots. So the first thing that we need to ask ourselves is, what is a box and whisker plot? Well, pull up that first tab where it says important note. What does it say below important note? Right, so anytime you're asked to construct a box and whisker plot, the first thing you must do is put the data in order from least to greatest. Now, below that, we're going to define box and whisker plot. So I'm going to reveal it, but don't start writing right away because I will tell you what you can put instead so that you don't have to write as much. Okay, let me zoom in to some. Oh, well, maybe a little more. Okay, so instead of rewriting a box and whisker plot again, because obviously we know that's what we're defining, and you don't even have to put a nice way, you could just start it with a way to organize data in a visual way to show variation. So basically, a way to organize data in a visual way to show variation. Now, who can remind me again what variation is? Hector, room 9. Just take the pass. Okay, what is variation? Right, how spread out the data is. And yes, range is one of the measures of variability, and so is mean absolute deviation. It shows how spread out the data is. So basically, a box and whisker plot is a way to organize data so that you can show how spread out the data is. Okay, now let's talk about the components that make up a box and whisker plot. Okay, starting with number 1. You see that over here on this box and whisker plot, number 1 is this little dot. Okay, it's this little point to the far left. Now over here on number 1, open up that flap and tell me what the definition of number 1 is. Okay, and it's called the minimum, right? Now, we also will call the minimum, or no, never mind, the minimum, sorry, I was getting ahead of myself. Okay, so that first one over there, that first point is the minimum, and it's the lowest value in a given set of data. Okay? Now, for this given set of data, what is the lowest value in it? 2. So under this flap, this number 1 flap, back where it says example, you can just write 2. Okay, so open all the way up to the back, and all you're going to put is a big 2, because that's all you'll be writing on that. Okay, so that's the minimum. So what do you think the point to the far right would be called, number 5? The maximum. Okay, and open up that flap 5 and tell me what the definition of the maximum is. Right, and we already knew that, right, when we did min and max last week. So that would be what number? 11. So under flap number 11, on that blank part in the back where it says example, you can write 11. Yes? Well, it shows the min and the max and the median, but it doesn't show the mean or the mode. Okay, the box and whisker plot is made up of 5 things. It's called the 5-number summary. And that's the min, the max, which we just covered, and then quartile 1, quartile 2, and quartile 3. The lower quartile, the upper quartile, which is quartile 3, and then the quartile 2 is your median. So we'll start with it next. Look under flap 3. What does it say that is? Flap 3 is the median. Okay, well, don't we already know how to find the median? So what should I do to find the median of this given data? Correct. Let's put it in order. So what's the lowest number? Correct, and there's 2 of them. And then after that, what's the next lowest? Right, we got a 4 down there. And then 2 5s. 8, Okay, now, is there an even amount of data or odd? Odd. So that means we're going to have exactly one middle number, right, girls? Pay attention. One middle number if there's odd. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the median, which is also called your quartile 2, let me write that in the darker. Okay, the median is also known as quartile 2, is 5. So up under that flap 3, you can put 5. Okay, so the median is quartile 2, and that's the middle of all the data. Now let's talk about quartile 1, which would be under flap 2. So pull up flap 2. It's called the lower quartile, and what's the definition of it? Right, the middle of the lower set of values. Well, this is the middle of all the data, so wouldn't the lower set of the values be everything to the left of it? Correct. So 3 is in the middle of that. So 3 is your quartile 1. So under flap 2, put a 3. And then, so now we have 4 components of our 5-number summary. We have the min, the max, quartile 1, quartile 2. And so what do you think 4 is going to be called? Well, quartile 3, which is also called the upper quartile. And what's the definition of it? Correct. And if you look at the higher set of the values, that would be everything greater than the mean. And what's in the middle of it? 9. So under that flap number 4, you can put a 9. Okay, so now what you just learned is the 5-number summary. And the 5-number summary is used to construct a box and whisker plot. You have to know those 5 things. You have to know the lowest number of all the data, which is the minimum. The highest number of all the data is the maximum. The middle of all the data is the median, and it's also called quartile 2. The middle of the lower half is called the lower quartile, or quartile 1. And then the middle of the upper half is the upper quartile, or quartile 3. Yes? Yes. Yeah, and then the upper was 7 to 11. You don't include the actual median in the lower or the upper half. Okay, now let's actually practice some of these in your packet. So turn to page 8 in your unit packet. Page 8. The directions at the top of the page say, use the stem and leaf plot below to answer questions 1 through 4. Now, stem and leaf plots, are helpful, like to write the data quicker. But honestly, when I'm answering questions about data, I prefer just to have a list. Okay, so we're going to take it from the stem and leaf plot and create a list of data. What's the very first number in the stem and leaf plot? Right, 122. Because remember, on the left side of the bar is the stem, and that's the first digits of the number. And on the right side is the leaves, and that's always just the last digit of the number. And it shows over here that that's how you read it, 122. So what's the next number in this data? 131. And then after that? Okay. Right. Okay. 146. 147. Right. Okay, so now we have our data ordered from least to greatest. And now we're going to answer these questions. Number 1 says, what is the value of the median? Who can define median for me? Right, the middle of all the data once it's in order, which it is. Okay, we do have an even amount of data, so it's going to split the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What do you do when you have 2 middles? You do have to add them together and divide by 2. But let's use our common sense here. When you're averaging, you're really just trying to figure out the middle of all the data. Well, if you've only got 2 data items and they're those 2 numbers, don't you just look at those and know exactly the middle is 143? Because 143 is 1 unit away from 142 and 1 unit from 144. So on something like that, you don't really have to type it in and divide, because you can just look at that and know that those average to 143 because it's right in the middle of those 2. So that would be B. Okay, now 142 and 144 split the middle, but they're not the median, right? The median is what we found when we averaged them, which was 143. Okay, so that's the median. So now this is not the median and that's not the median. This is the median. Which values are in the upper half of the data set? Upper half? Upper would be greater than the median. So D, the upper half is all of the numbers greater than the median. And all the numbers greater than the median are this way. So 144, 146, 147, 155, 159. The upper half are the bigger numbers to the right, because upper, they're above. Just remember the upper like numbers that are above 143 are 144, 146, 147. So they're called the upper half. Okay, so the lower half would be 122, 131, 133, 134, and 142. Okay? Now, on the example we had in the book that we did, there was only one middle number, right? And that was your median. So it didn't get included in the lower half or the upper half. But if 2 numbers split the middle, once you average them, those 2 numbers will go into the lower and the upper half, okay? Only the actual median stays out of the lower and upper half. Okay, what is the value of the first quartile? Okay, who can tell me what first quartile, like the definition is? Right, the middle of the lower half. Well, we just got finished saying that the lower half would be from 122 to 142. And what number's in the middle of those? 133. So that's your Q1, your quartile 1, or first quartile. It's also called the lower quartile. Okay, now let's think about this for a second. It says, what is the interquartile range? Tell me what just regular range is. Correct. Regular range is when you do the max minus the min. So, Collis, what do you think interquartile range would be? Correct. Okay? Interquartile range now deals with the quartile. So instead of just doing the max of all the data minus the min of all the data, you're going to do the maximum quartile, which would be quartile 3, minus the minimum quartile, which would be quartile 1. Well, we just found quartile 1 a while ago. It was 133. And then how can we find quartile 3? Isn't it the middle of the upper half, which is 147. And so now we just subtract those, and what is 147 minus 133? 14. Now most of the time you'll see it written out as IQR, interquartile range. Okay, well, is it regular range, the maximum minus the minimum? So that means interquartile range is the max quartile, which is Q3, minus the min quartile, which is Q1. The highest quartile minus the lowest quartile. All right, now let's create an actual box and whisker plot down here with number 5. Okay, so first thing you need to do is draw a number line. Just try to get it as straight as you can. Okay, and the information given to us in number 5 is the 5-number summary. So we're not actually having to do any kind of calculations. They went ahead and gave us the 5 components we need to construct the box and whisker plot. We just have to know where they go. The first thing, though, you need to decide is how to scale your number line. You know that it's got to go all the way from 89 all the way to 168. So I would start it maybe at 80 and finish it at like 170. And then I would go by intervals of 10, like 80, 90, 100, 110, 120, 130, 140, 150, 160, 170. So we're scaling it all the way from 80 so that it will include room for the 89, the minimum, all the way up to 170 so that there'll be room to plot the maximum, and it's going by intervals of 10, but I'm just going to write every other interval. So that's 90, so that's 100. That would be 110, so this would be 120, 130, 140, 150, 160, and then that line would be 170. So the scale is from 80 to 170 so that it will include all of our numbers, and the intervals are by tens. We're going by tens. But we just wrote every other value. Okay, the minimum and the maximum make up our whiskers, and they are constructed by just a point. So my first point would be at 89. Well, this is 80, so that's 90. So would 89 be like a hair before that line? Okay, and then I'm going to go and label that min. Okay, so now we need to do our maximum, which is at 168. This is 160, that's 170, so 168 would probably be about right there. I mean, you know, it's just an estimate because this is a hand-drawn graph. Okay, so those are going to construct the whiskers. Now we need to construct the box. The box is made up of 3 lines. Okay, the lines are the 3 quartiles. So the first quartile, quartile 1, is at 125. That's 120, and that's 130, so wouldn't the first line go right in the middle of those? Okay, and then after that, quartile 2, which is also known as the median, is 144. Well, there's 140, and that's 150, so 144 would be like a hair before the middle. Right there about. Yeah. And then the third quartile, quartile 3, is at 152. Well, that's 150, so 152 would just be like about right there maybe. Okay, once you have your lines for quartile 1, the lower quartile, quartile 2, the median, and quartile 3, the upper quartile, all you do now is just connect them to close it in and make it a box. And then after that, you connect the box to the min point and to the max point, and those are your whiskers. Now, some information to know about the box and whiskers plot is 50% of the data falls inside that box. So 50% of your numbers, like if you had 10 data items, what's 50% of that? 5 of them. 5 of them would fall within this box. 25% of them would go outside the box on the left side between the min and quartile 1, and then the other 25% would go on the other side between quartile 3 and the max. And see how that adds up to 100%? Okay, now for the next few minutes, I know these are ugly, but you have a calculator. I want you to work with the person beside you. Find the minimum number of these 14 numbers, the maximum, and then find the median. You got to do the median first, and then after that, the quartile 1 and quartile 3. Work with somebody beside lowest value up there. Right, 0.215. And then as I write them down, I mark them out so that I don't go back and use it again. Then after that, okay, 0.231. 0.236. And then 0.240. Okay. Okay, then after that, okay. There's 2 of them, 0.260s, okay. 0.267. Okay. Okay. Everybody pay attention. Okay, then after that. Okay. Barely got it in there. Okay, now, I don't know if anybody had trouble writing these in order from least to greatest, but if you do, try to think of it like this. Just ignore the decimal point and think of it as 215, 231, 236. Okay, so if putting them in order was hard for you because they are in decimal form, just kind of like put the decimal point out of your mind for a second and just look at the three numbers, and then it should be easy to put them in order from least to greatest. Okay, now that they're in order from least to greatest, we need to get our 5-number summary. What are the components of the 5-number summary? No, like not the actual answers, like the words. Right, the min and the max. Right, the quartile 1, which is also sometimes called lower quartile. Quartile 2, which is sometimes called or always called the median. And quartile 3, which is called the upper quartile. Okay, what is the minimum of this data? Right. That is the lowest number. What is the maximum? 0.295. Okay, now, when you go to figure out quartiles, you have to do them in a particular order. Which one do you have to find first? The second one, the middle of all the data. Well, we can see that there were 14 teams, which means it's even, and we're going to have 2 middle teams, right? 2 middle data items. And where are they going to be in the middle? 7 over, right? Because 14. So 1, 2, 3, 4, 5, 6. Wait. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Well, that ended up pretty easy because even though there were 2 middle numbers, what's the average of 0.260 and 0.260? 0.260. Now, this is where you got to pay attention. Yes, 0.260 is the median, but since there were 2 of them, you still get to include one of them in the lower half. So the lower half goes all the way from 0.215 to 0.260, and the upper half includes that 0.260 and goes all the way to 0.295. So now the lower half is made up of 7 numbers and the upper half is made up of 7 numbers. And in the lower half is where we can locate quartile 1, the lower quartile. And what's in the middle of those 7? 0.240. And then what's in the middle of the upper quartile? 0.270. Okay? So now we have the 5-number summary, which is what we need to construct a box and whisker plot. So now I'm going to draw a horizontal line to be a number line. And what I did on my number line, just to make it a little bit easier, is I rounded them off. Like, I just wrote 0.21. And then on the next one, I wrote 0.22, 0.23. Oops, forgot the 2. 0.24, 0.25. I mean, if you wanted to, you could have written out a 0 on the end, like 210, 220, 230, but I just went ahead and shortened them. And then 0.26, and how far do I have to go? 0.29 at least, yeah. 0.28, and then 0.29. Okay? So my scale went from 0.21 to 0.29. And now I'm going to plot the minimum and the maximum. The minimum is 0.215, so pretty much just right there. And then the maximum is 0.295. Okay, so there's my min and my max. And now for the quartiles is where I draw the lines of the box. So quartile 1 is at 0.24. And quartile 2 is at 0.6 or 0.26. And quartile 3 is at 0.27. Okay? And then you will connect the whiskers to the box. The min and the max connect to the box, and those form the whiskers of the box and whisker plot. Does that make sense? Now remember, 50% of the data falls within the box. Okay, the box contains 50% of the data. 25% of the data would be below it, and 25% would be above it. Okay, to make up 100% of the data. All right, now let's turn to page 9. The directions at the top say, use the box and whisker plots below to answer questions 7 through 10. These box and whisker plots are showing bowling scores for 3 different bowlers, bowler A, bowler B, and bowler C. Which bowler had the highest median score? Okay, so keyword median. Where is the median found, Collis, in a box and whisker plot? Right, the middle line of the box. So like that's the median for bowler A, that's the median for bowler B, and that's the median for bowler C. So let's ask some people. Let's see. Landon, what is the median value for bowler A? Correct. Okay, bowler A had a median value of 220. Sierra, what is the median value for bowler B? 200, right? And then Ethan, what is median value for bowler C? Remember, the median is the line in the middle of the, well, not necessarily in the middle of the box, but inside the box. And isn't that line for bowler C at 210? Okay, now remember, the median is the line inside the box. So like, see the ones I highlighted orange? That's the median line for bowler A. And if you follow it down, it was at 220. This is the median line for bowler B, and if you follow it down, it's at 200. And that is the median line for bowler C, and if you follow it down, it's at 210. So does everybody see how to spot the median line and see the value of it? So which bowler had the highest median? A. Okay, 8. Which bowler had the highest single gain? Right, A. Why? Correct. Isn't bowler A's maximum score way over here at 260? So he had the highest single gain. That was his maximum score. Which bowler had the lowest single gain? Which one has the lowest minimum? C. Aren't the minimums the dots on the left? And so that one by bowler C is the lowest minimum score. So that bowler had the lowest single gain. Okay, number 9. Which bowler had the broadest range of scores over the season? Now, broadest would be another word for like most spread out. So, greatest variability. Now, yes, but let's talk about a more mathematical way of figuring this out. Remember, broadest range is talking about spread, which is variability. Well, isn't one way to find variability range? Or interquartile range? Okay, well, how do you find range from just looking at the box and whisker plot? Okay, Collis? Correct. You do the maximum minus the minimum for bowler A. What was the bowler A's maximum? 260. What was his minimum score? I'd say 195, because doesn't it look to be right in the middle of those two, which is 195? So his range for the season was 65 points. Okay, now to find interquartile range, what would we do? Okay, Collis? Correct. Q3 minus Q1. What is bowler A's Q3? 230. What is bowler A's Q1? 200. So his interquartile range is 30. Okay, now I want you to take a minute and I want you by yourself to figure out the range and IQR for bowlers B and C. For regular range, remember it's just the maximum minus the minimum, which is the whiskers. So the maximum for bowler B was at 220 and his minimum was at 180. So he has a range of how many points? 40. Interquartile range is still range, so you're still subtracting the highest minus the lowest, but this time the quartiles. The highest quartile is at 210, and the lowest quartile is at 190. So that's a difference of 20. Okay, and then for bowler C, his maximum score was 250. His lowest score was at 170, so he has a range of 80 points, and then his interquartile range was his quartile 3, which is at 215. Oops, I don't know why I wrote dash. And then his lowest quartile, quartile 1, was at 185, and so his interquartile range is 30. Okay, so now that you see it in numbers and not just looking at the picture, which bowler had the broadest range of scores over the season? C. Okay, their interquartile ranges matched up for A and C, but the bowler C definitely had the largest range of 80. Okay, which bowler was probably the most consistent from game to game? B. See how his numbers for range and interquartile range are small? That shows less variability, less spread. Now, does that mean he was a good bowler? No, he was just consistent at bowling bad, right? Okay? He was consistently the worst one. All right, now below. Journal questions. What does the box in a box and whisker plot represent? Explain what it means if a box and whisker plot has a very long box with very short whiskers. You're going to answer that on the back on page 10. You're given some lines. So turn to page 10 and try to answer that question by yourself for a scenario in which a box and whisker plot is only a vertical line. That is, it has no box and no whiskers. So visually, it would look like this. You would have your number line, and then when you went to construct it, it would just be like this. What? Right. It would all be the same number. Like if you had a list of numbers that was like 5, 5, 5, 5, 5, 5, 5, wouldn't the median be 5, and the median, the lower half be 5, and the median, the upper half be 5? Okay, and the min and max would be 5. So that would be a scenario when you would only have a vertical line, is if the list was all the same number. If you have a list of all the repeating numbers. Remind me in a minute to write your name down. Okay, number 3. Well, I'll give you a second because I still see people writing. All right, number 3. Maria surveyed 19 students in her math class to determine the number of test questions each answered correctly on the last exam. She put the results in the following stem and leaf plot. So what you see below is like a stem and leaf plot that shows 19 kids in her class and how many questions they got right. So like the person who did the worst, how many did they get right? 22. Correct? Because up there, isn't that 2 and then the bar 2 representative of the number 22? So the person who did the worst only got 22 questions right. The person who did the best got how many right? 100. Okay? Now, she is saying that she determined the median number of questions answered correctly was 79. Was she correct? Okay, don't say it out loud. I want you to figure out if the median is indeed 79 by yourself. The numbers should always be in order when they're in the stem and leaf plot, but she messed up when constructing her stem and leaf plot, and that's why her median was incorrect, because she probably just went through marking them out, and if you do it that way, yes, it will take you to 79. Watch. If I keep going. See how if you mark them out along the stem and leaf plot, you do end up at that 79? But she had not put her stem and leaf plot in the correct order, so that's why she was wrong. So that's what you would put for number 3. Okay, now last question. Shh, come on, let's get this last question done. All right, explain why it does not make sense. Like, why would it not make sense for me to ask you how many data values are in the third quartile? Why would that not make sense if I said how many data values are in the third quartile? Right, in the third quartile, just one number, the median of the upper half. So that's the answer to number 4. The third quartile is just one number. It's the median of the upper half. So it would never make sense for somebody to ask you how many numbers are in the third quartile because it is just one number.